Hello, my name is Radim, and in this video I'd like to introduce the Keboola connection platform, give an overview of the basic functions, and share some tips and tricks that might be useful. Hopefully, after this video, you will be able to navigate through Keboola connection and perform basic tasks. It might seem overwhelming at the beginning, but once you grasp the basic concepts, the rest is a piece of cake. Firstly, I will briefly discuss high-level architecture. After this, I'll get to the building stones of Keboola connection platform. I'll start with Extractors, next on the menu will be storage. I will show you how we store tables and files, and some cool features Keboola connection storage has. Then I'll briefly talk about transformations and writers. Wrapping up, I'll show you how to check if your process is passed successfully, and how to chain all the components to make an automated process. Lastly, I will mention the guide mode and give you a secret code which you can use for spinning off your very own Keboola connection project with an interactive guide. So, what is Keboola connection? We like to talk about Keboola connection as about a cloud data integration platform. This means that it allows you to connect all your data sources, merge them, enrich the datasets, and load them wherever you want to consume the data. And all of this is happening in the cloud, so you don't need to worry about maintaining the infrastructure, and you can rather focus on the actual work with data. Keboola is like a Lego for ETL. It is basically a vast collection of components you can easily combine together and make highly customized pipelines. All the components are Docker-based, so they do not depend on each other. Each of them runs in a separated environment, which allows for easy debugging, and the fact that all the intermediary tables are stored in the Keboola connection storage allows you to inspect the process in detail and optimize it. And because the components are not dependent on each other, you can easily run several components alongside each other. For example, if your process needs data from multiple data sources, you can download from all of them at the same time and minimize the runtime of the whole process. I'll start with the extractors. Extractors are usually at the very beginning of each pipeline. You need to get fresh datasets to process. We can connect to various data sources, such as CRM systems, databases, or marketing sources. If you need your database to be safe, and I bet you do, you can use SSH tunnel to connect to it. Or if you want to decrease the amount of data that needs to be transferred, you can fetch only rows that were changed after the last extraction. For many of our components, we allow for incremental fetching. The method in which it happens is varied across our sources, but where it's possible, we will have it as a feature. If you are interested further, each extractor has their own documentation that will describe the method in detail. Incremental loading, for those that do not know, is allowing us to extract just a subset of data from the source into the target. It works in an upsert style based on the primary key. Where the row already exists and there is a change in the values in the row, it will update the record. Where the record doesn't exist, it inserts the record. When you are configuring an extractor, you need to give it some credentials it can use for connecting to the source and specify the data you want to fetch. Let's say you want to fetch some data from MySQL database. In the credentials section, you need to specify the hostname, the port, the username, obviously password, and the database you want to fetch from. Once you have specified all this data, you can test the credentials. We have successfully connected to the database. So now you can specify some of the tables you would like to fetch. So let's say I want to get a table that's called addresses. I can set up the primary key, and I can select a query for the actual fetching. If I don't specify a query, all columns will be imported. It is also a case when you want to extract data from somewhere else than a database. In that case, you can use our pre-built components, or if the source has some sensible API and we don't have a component for it, you can use our generic extractor. Take a look into our docs on help.keboola.com to find the generic extractor tutorial that will show you how to connect to a REST API by using a JSON configuration. For other sources that we don't have listed, first contact support or your customer success manager to see if there are any unlisted components that exist. Where that fails, you can build your own custom component. Ask support for our materials in order to learn how to do that. Storage is where all the tables and files live inside Keboola connection. The tables are organized in buckets. This is effectively the same as folders on your laptop. The storage has three tabs: buckets, files, and jobs. The jobs section contains a complete log of the actions that were performed on the storage tables. You can find there when someone imported a table, exported a table, or even fetched a preview of a table. For example, this event shows that we imported some data into the table. It shows when it happened, how many rows we imported, and what columns did the file contain. Next tab is called Files. It shows all the intermediary files that are being transferred behind the scene. So, e.g., this CSV is what the extractor downloaded from the MySQL database, and you can easily download it should you need to inspect the file further. Just click on it, and you see it's being downloaded. Last, and surely the most used tab, is called Buckets. Here you can see all the transactional tables you have in the project. As mentioned earlier, each bucket can contain more tables. The Overview tab shows you when was the bucket created, when was it last updated, and what is the total number of rows in the bucket. It also shows you which tables the bucket contains. The Events tab is basically the same as the Jobs section of the whole storage. Only this time it is filtered for jobs connected to this bucket. If you click on a table, you'll get to a detail of a table. A lot of what you see is pretty self-explanatory, but I would like to bring your attention to two tabs. First is the Data Sample. This will show you several rows from the data, and you can get better understanding of what the table contains. It also allows you to do some basic filtering. Next tab is Snapshot and Restore. By default, we keep 7 days history for a table stored on a Snowflake backend, so you can roll back a few days anytime. The snapshot feature allows you to keep snapshots of the table. These are stored indefinitely, and we usually use them before we make some big changes in the table. This way, we can easily restore the table in case we find out the changes were destructive and we don't lose anything. Feel free to explore the storage more. A comprehensive manual is linked in the description. I also included a slide in the presentation that lists all the key terms you should get familiar with. Another key part of Keboola connection are transformations. This is where you process the data you get from the extractor. Currently, you can use 4 backends for doing so: Snowflake-powered SQL, Python, R, and OpenRefine. Every transformation runs in a separate container, so you have to specify the input and output. This basically says which tables from storage should be loaded into the container and which tables should be loaded from the container back to storage once the transformation is finished. Once you have the input table specified, you can load a sandbox and start developing your transformation. So let's say I want to transform the data I downloaded from the MySQL database. I'll create a new bucket here in the transformation section. Buckets and transformation sections are like folders for transformations. You usually use one bucket for one bigger task, and usually when you are building an automated workflow, you run the whole bucket. But let's get back to transforming data. We have a bucket, now we add a transformation. I can here choose the backend. I will choose Snowflake because I want to use SQL. Here I drop some description, so when someone else sees this transformation, they know what it is about. Then I will create it. The transformation has been created, and now I can specify the input mapping. Let's say I want to process the orders table. I download it. Then, for developing the transformation, I will load a sandbox. As you can see, the credentials popped up on the screen. So I will click Create Sandbox, and I will connect to it. I will take the user, then I will copy-paste the password. I can see that the sandbox has been successfully loaded. So let's say I just want to filter the data, something very basic. So I do something like create or replace table out orders as select all from the table orders I specified in the input mapping. I will run the query, then I will refresh the list of objects, and then I can check if the query actually did what I wanted it to do. Yes, this looks good. So once this is done, I can copy-paste the query back to the production environment. I also have to specify the output mapping here, which I will do like this. I will specify a new output. The table in the transformation we created was called out orders. Then I will specify the destination. So let's say I want to put it to this bucket out C Radim basic training, and I would like the name orders. There are also some advanced features and functionalities, but let's not get to them right now. Then I will create the output. I will save this query, and then I can validate the SQL. If you click validate, it goes through your SQL and looks for basic problems. It doesn't catch every mistake, so sometimes the SQL is still invalid, but it's pretty nice. Now I know that my SQL is valid, so I can run the transformation. Here you see that the job has been started. The label partial is there because we ran a single transformation in a bucket. As I said, standard is running whole buckets in production. Okay, the transformation passed. Now we have a brand new table in the storage. I want to show you one more thing, and it is this section in the transformation UI. This allows you to inspect all the changes that has been done to a transformation. So for example, here you can see I created the transformation. Here you can see I specified the input mapping. And here you can see I create the output mapping, and here that I changed the queries. If you wanted to see what I changed in the queries, you can click on the row and it will show you the detailed difference. This is super useful for debugging. There are also some advanced features such as dependencies, which allows you to execute multiple transformations from one bucket in one container in a specific order, or phases. This again allows you to specify the run order. Link to the documentation in the description. Writers can be used for writing the data out from Keboola connection. They are basically the exact opposite of extractors. They take data from the storage and load them somewhere outside Keboola connection. Again, we have a broad range of writers which you can browse in the writers section. But let's try it hands-on. Let's say we want to write the transform data to another MySQL database. First, we need to add the credentials and test them. Once it's done, we choose a table from the storage, specify which column we want to load, and how should the resulting table be named. Let's say I want to choose the order. I can leave there all the columns, and I can change the name to orders in uppercase. There is an option to choose incremental load. This load basically performs an upsert to the target table. It checks the primary keys in the database table, updates those rows that are present in the table we are loading in, and append the rest of the table we are writing to the database. Not all writers have the same setup, but all of them are rather intuitive and have a documentation, so you should be able to set up any writer. In case you run into any trouble, there's always an option to contact support. Here. This opens a pop-up and you can describe the problem there. The URL you are on is also documented there, so please open it from the component you need to help with. There is also a trash section in the project. This section contains all the configs you have deleted from your project. You can easily restore any one of them, which is super nice. But be careful, because there is a catch. If you authorize a component, and then you decide you no longer want people in the project to be able to access the target system, simply deleting the component is not enough, because anyone can then restore the configuration, which would still be authorized. That's why there is an option to delete forever. Use this carefully, because it does exactly that. It deletes the config, and it cannot be reverted. The last part of KBC I'd like to show is called Orchestrations. Orchestration serves for putting all the Lego pieces together. In this section, you can build your custom automated process, chain all the components, and specify when should the process be executed. Let's say we want the process we just built all parts for to be running every day at 8 AM. So we start with creating a process for it. Then we specify what should the process do. Here we specify we want the extractor to be included in the phase 1. The transformation will be in phase 2. And in the end, we will put the writer to phase 3. The phases are executed sequentially. The tasks in one phase are executed in parallel. This means that if we had more extractors, we would put them all to the first phase and have them run at the same time. The same holds for the writers. And if we had independent transformations, we could put more of those to one phase as well. So now we have specified what we want the process to do. Now we can specify when we want the process to run. So we open schedule, and we specify that we want it to be run every day, let's say at 8 AM. Please note that all the time is in UTC. There's also a possibility to have the process started when some specified table changes, but let's not get into that now. Then we'll save this. Okay, and last but definitely not least, we need to specify notifications. Notifications are sent to specified emails every time the process ends with an error or a warning is raised. This effectively means that you don't have to worry about the process at all until you get a notification. So let's say I want to be notified whenever the process fails or is taking longer than usual. I will just type my email here . And I can be sure that whenever something is wrong, I will get an email. Pro tip, if you are using Slack, you can set up an email integration and have the notification sent to a channel in your Slack workspace. This is basically all you need to know to start with Keboola connection, but I promised you a secret code for guide mode, so don't close this video just yet. If you go to try.keboola.com and use the code guide mode, you will get your very own Keboola connection project with an interactive guide. After watching this video, it will be probably fairly easy for you, but it will mention some things I went over just briefly or skipped completely. It is not long, you will get through it in an hour easily. This is the list of resources. I strongly recommend to go through them before you start building something substantial in Keboola. I hope you enjoyed this video, and in case you have any feedback or any questions, don't hesitate to drop me an email to radim.kasparek@keboola.com or contact us via the webpage. Have a nice day!